morning, friends. As we discussed in the previous class, previous online class, that we will be discussing about the design of bench terraces today. Under design of bench terraces, we have also studied about the bench terraces in the previous class. What is bench terrace, or what are terraces rather? Terraces can be classified as two types: broad-based and the bench terraces. Even in broad-based, there are two types: graded and drainage type. And most importantly, in bench terraces, we have basically three types of bench terraces. The first one is the level bench terrace, then is inward sloping bench terrace, and the outward sloping bench terrace. The level bench terraces are used basically for absorbing the rainfall, whatever rainfall is received, and is used in medium rainfall area. The inward sloping bench terraces are used in areas where the rainfall is pretty high, more than 1000, 1200, 1500 mm in a year. Average rainfall is more than 1500 mm, and the basic purpose is to conserve that moisture, and also if there is excess rainfall, the inward grade will necessitate the excess rainfall to flow from a channel which is constructed near the cut side of the bench terrace. Then again, we have the outward sloping bench terraces. This outward sloping bench terraces is provided with a shoulder bunt, so that the whatever rainfall occurs, and one should remember that outward sloping bench terraces are constructed in areas where the rainfall is less, and whatever rain which comes as rainfall, it has to be conserved, it has to be absorbed in the benches. And if in case there is a excess rainfall, the shoulder bunts will obstruct the movement of water and will not allow the excess rainfall to escape from the benches. The basic design of bench terrace, this is your sloping land. What you do is we cut the length of the slope in such a manner that the length of the slope is decreased, and finally what we get is a series of step-like structures of platforms. So a land which is more than 20 to 30% generally sloped area, especially talking about bench terraces. Broad-based terraces are constructed on a flatter land, and not the entire land is cut or filled, but it is divided into series of mildly sloping ridges and furrows. But here we are specially talking about bench terraces. Whenever we talk about terraces, the first thing that come to our mind is bench terraces, because it is most widely used, especially in terrains like ours. So for any cultivation, we require normally leveled surface. This bench terraces enable or ensures us that in a steeply sloping land, we can convert into a series of step-like structures or platform-like structures, where cultivation of even rice can be possible, or vegetables can be possible, or even orchards can be planted in such type of terraces. So this normally 20 to 30 or even more sloped area can be converted into a series of benches. These are called benches. And this is your cut portion. Some land has to be cut, and the same the cut land has to be filled in the downstream side. This is your fill. This is your cut, and this is your fill. So ultimately what happens is we can get a platform-like structure, and this is your depth of cut, because we are not cutting the entire length, because this cut as well as fill takes place, and your total depth will be this cut plus this is your total depth, or this is also called the vertical VI, vertical interval, or we call it the spacing between two buds. And this cut or depth of cut will be, d by 2, because this is the vertical spacing. Cut will be half of the spacing between two buds. Basic thing about the construction of a bench terraces, if we have to design, what are the design requirement, what are the things that we have to consider for designing a bench terraces. First is we have to understand what should be the type of bench terrace. So the steps involved in construction of bench terraces, the basic consideration, one is to know what should be the type of bench terrace. Should we go for inward sloping, should we go for outward sloping, or should we go for level type of bench terrace? That will of course will be determined by the average rainfall of the area. As explained earlier, if the average rainfall is medium, then we go for level top. If it is high, then we go for inward sloping, and if it is low, then we have to go for outward sloping with a shoulder bund, inward sloping with a channel. Second is the terrace spacing. So, second thing that we have to determine is the terrace spacing or depth of the terrace spacing is the vertical distance or the vertical interval between two successive benches. So it will involve both the cut as well as the fill, right? And for this, what determines the terrace spacing is your depth of the soil or the soil type. If say the soil depth is less, if the soil depth is less, then we cannot go for deeper cut, because if places where the soil depth is less, the hard surfaces will be exposed very early, and we will have some limitation about the depth of cut. If the soil depth is say 0.3, 0.5 meters, then if you want to go for 1 meter of depth of cut, it would be very difficult to cut through the hard surfaces. So that would be a limitation. So the depth of the soil will determine your depth of cut. And also the terrace spacing will also determine what type of cut we will have to do. Shall we go for a vertical cut, or shall we give some certain slope? The first case diagram that we discussed was a vertical cut one. But for a vertical cut, what I mean by vertical cut is like this. The cut will be vertical. There will not be any slope here. This is called your riser. This is your vertical cut. Now, vertical cut, for going for vertical cut, we cannot go beyond 1 meter of cut, because if the soil depth is less and we have to go for vertical cut, the soil should be stable. By soil to be stable means it should be clayey type of soil. The stability of the soil will be in question, because if it is a sandy type of soil or if it is unstable soil, this cut will not be sustained. Over a period of time, it will score and it will be damaged. For such type of situation, we will be required to put some retaining wall made of stones. So whenever you go for vertical cut, it is necessary. First thing, it cannot go beyond 1 meter, and second thumb rule is that it has to be supported with some logs, wood, whatever local material is available to retain that vertical type of cut. Otherwise, you have to go. One has to go for some better slope has to be given. How? So this is not vertical cut, but we are giving a slope of 1:1, that is horizontal is to vertical. So this is called your riser slope. We also call it batter slope. So a batter slope of generally 1/2 or 1:1 is given, so that the cut will be more stable, and it will not fail against high rainfall or soil erosion. So for stability, we give this better slope or riser slope of 1:1. So 1:1 means this is your vertical interval represented by D, and this is your width of the terrace. Had it been vertical cut, it would have been like this. And since we are giving a better slope of 1:1, so this cut will be D by 2, and this is W by 2, and this will be W by 2, and this, since we have 1:1 slope, if the vertical is 1:1 means horizontal versus vertical. If vertical is half, then horizontal will also be D by 2. So this is your depth of cut, and this is your horizontal spacing between two bunds. And one thing that you have to remember is this vertical cut, although it won't be stable, but the area lost due to bench terraces in vertical cut is less compared to having 1/2 or 1:1 better slope. Because 1:1 better slope, this area we cannot have any cultivation, and if such type of over a coverage of 1 hectare, it will almost be like 20% of the land area, surface area will be lost because of this construction of bench terraces. Then again it is a loss. Again, if you have a vertical cut, the stability of the structure will be in question. So always there has to be a compromise between the area to be covered under bench terraces and the stability of the bench terraces. Even 1/2, wherever the soil type permits, 1/2 better slope is also given. And for any bench terraces, one should always remember this: cut should be, for economic reason, should be equal to whatever the cut material is there, it is deposited, it is put on the downstream side. The third thing is designed is the terrace width. What is the terrace width? This is your terrace width. And if we have a better slope of 1/2 or 1:1, we will have this slanting riser or batter. Then this is your horizontal spacing. This will be W by 2, this will be W by 2, this is D by 2. And if it is 1:1, it will be D by 2. If it is 1/2, it will be D by 4. I hope you are getting it. So terrace width is also a function of what type of crop you are growing. We can fix the terrace width. If we want a particular crop to be grown, if the crop grown is manual, then a certain thumb rule is there that certain width is permissible. If machine has to be put there, if tractor or power tiller has to be used for tillage, then the width should be wider. Normally for manual cultivation, the terrace width kept is 3 to 5 meters, and if we have machine cultivation, at least 10 meter, 8 to 10 meter of terrace width is advisable. Again, the steeper the slope, say this type of slope we have, the narrower will be the terrace width, because we cannot, for cutting the soil, we have certain limitation. We cannot go beyond a certain limit, 1.5 meters. And if the slope is very steep, then the width will be less. Say if it is milder, then we can have the leverage for having a wider width. If it is steep, then we have to go for narrower terrace width. Now, fourth thing which is important in terrace design is the terrace cross section. So, terrace cross section is important where, especially for inward sloping bench terraces, where we give a certain grade, so that the excess rainfall which falls on the terraces on the terrace bed is drained off through a channel bed. So for inward sloping terrace bed, the grade is important. Normally 1:8 grade is given on the terrace bed. And also the channel bed has to be designed. Should it be parabolic? Should it be trapezoidal? That channel bed has to be. We won't go this far, but we'll limit ourselves to the terrace spacing and terrace width, and also the area lost due to bench terraces. Now, second thing in terrace cross section is like in outward sloping bench terraces. Outward sloping. So there has to be a shoulder band. And what should be the cross section of the shoulder band? Normally the cross section is bottom width is kept as 120 centimeter, top width 40 centimeter, and the height in this case is kept at 45 centimeter. This is a thumb rule, although much design is not required here, because seldom it will happen that there will be excess rainfall in excess runoff in low rainfall zones. So it will happen once or twice in its lifetime, or maybe once and twice in 5 years. So for that condition, we have to keep a shoulder band. This dimension has to be like this, and it is very unlikely, but still we will keep the shoulder band. And the band over the period of time, since it is dimensions are not that big, height is not that big, cultivation is also possible on such type of shoulder bands. So these are the basic design considerations. Type of bench terrace spacing or depth of cut. Third is terrace width. Fourth is the terrace cross section. So I am putting these slides so that when the final product comes, the presentation can be put so that the diagram is more clearer to you. So I will request the people involved in this work to put the presentations also simultaneously, so that especially the diagram is more clear to you, because here due to reflection or something or many other reasons, or maybe sound effects, things would not be that clear. Once the diagram is clear to you, it will be more easily understandable to you. Now, these are the design consideration of bench terraces, and what are the datas involved? What are the data that we require for design of bench terraces? For that we require average rainfall data of the area, Second is soil type and depth. This average rainfall data of the area would be required for understanding the type of bench terraces that we have to construct. We go for inward sloping, outward sloping, or level one? And soil type and depth of soil would be required to understand, to design the terrace spacing. This data would be required for determining the terrace spacing. Third is, the average slope of the area. As already discussed, the slope of the area will determine how much width we can go for a bench terrace. If we want broader benches in a steeper land, then you have to compromise with the depth of cut. More depth would be required. Right? Then there would be some problem in the stability of the structures. But steeper the land, lesser will be the terrace width, and milder the slope, more broader will be the terrace width. And fourth is your crop and soil management. What type of crop we are growing and what type of soil management that we are doing, that will also determine the terrace cross section. Because the crop, say for an orchard plant, it won't be necessary to have the complete benches or terraces. The places where if we have very steeper land and going for benches across the board would be difficult. Here what we do, we go for hill type of bench terraces. This place where we have to plant any tree, here we make small benches, leaving the other inclined area as such. Here we will be planting the tree. So depending upon the crop and the soil management, we can also decide upon the tillage cross section. Now coming to design of bench terraces. The first thing that we have to understand in a bench terrace is what should be the type of bench terraces. Of course, the rainfall of the area will determine the type of the bench terrace. Say suppose we are making level bench terraces. For the sake of simplicity, we will go with the level bench terraces, both vertical cut and with a better slope of 1:1 and 1/2:1. Say case 1 for vertical cut. Vertical cut means the depth of cut would be vertical. This is your cut and this is your fill. Whatever cut is there, fill should be the same. Right? And this is a case of similar triangle as well. And this is your length or width, because length and width would be same since the cut is vertical. And this is your vertical spacing and this is your horizontal spacing. This is your vertical spacing. And this will be, since this is W, this will be W by 2. Any doubt? No. And this is the vertical spacing, is the spacing between two successive bunds. It involves both cut as well as fill. But we are more concerned about the cut. This cut will be, if it is D, this will be D by 2. Right. Then what do we know? We know Bi by Hi is S by 100. So this is S, this is 100. Then what is Vi here? D, Hi is W, so D is equal to Ws by. Okay. So for a vertical cut, the depth of cut will be W into slope divided by 100. Similarly, we can find W through this equation. Right. And second case, for better slope 1:1. For the better slope 1:1, the entire scenario will change. When we have a better slope of 1:1, that means we are giving a certain grade here. So why do we do this? If the soil is not stable, or secondly, when we have to go for depth of cut beyond 1 meter, and also the soil type does not permit, and also where we don't have locally available rocks or any materials to retain the depth of the cut, then we have to go for better slope, either 1:1 or 1/2:1. So here, this is the vertical spacing between two successive benches. This is D. This is the horizontal spacing L, and this is your width of your bench terrace. And obviously this will be W by 2, and this depth of cut will be D by 2. Since we have 1:1, one horizontal to one vertical, if the vertical is half, this will be also half. If it is 1, it will be 1. If it is D by 2, this will be D by 2. Now, since it is a case of a similar triangle, the laws of similar triangle, we have here D by 2 by this one, W by 2 plus D by 2, D by 2 plus W by 2 is equal to S by 100. Which is equal to, solving this, we can find 100D is equal to SD plus WS, or D is equal to WS by 100 minus S. If we solve this, you get this equation. So, when the better slope is 1:1, we get the equation D as WS by 100 minus S. So these equations are important. It would be helpful for you for design or to determine the depth or the width of bench terraces. Now, third case, if for the better slope, if it is 1/2:1, that is horizontal is to vertical. So if in this case, if the vertical is D by 2 and the horizontal is better slope is 1/2:1, for one vertical the horizontal goes half. So if the vertical is 1, this will be half. If vertical is D by 2, and this will be D by 2 divided by 2, that is D by 4. Any doubt? Rest will be same. So again putting that for the third case, d by 2 by, it's again the case of a similar triangle. So d by 2 vertical is to horizontal, vertical by horizontal is the slope expressed in percent. Vi by hi is equal to s by 100. Vi here is in this triangle, it is in this similar triangle, it is d by 2, hi is d by 4 plus w by 2. S by 100. If we take 1 by 4 as common, will become 2d by d plus 2w equal to s by 100, which implies that d is equal to ds plus 2ws, or d is equal to 2ws by 200 minus s. This is your case 3 when the better slope or the riser slope is half is to 1. So we have three situations for horizontal vertical cut. We have d is equal to w s by 100. For the better slope 1 is to 1, we have d is equal to w s by 100 minus s. And for better slope half is to 1, we have 2ws by 200 minus s. It's not always required to derive this at your stage. You can also remember this by a general equation. D is equal to ws by 100 minus s into sr, where SR is the riser slope or the better slope. For vertical cut, riser slope is 0. It will be ws by 100. For riser slope of 1 is to 1, it would be s into 1, ws by 100 minus s. For riser slope of half is to 1, s into, this will be half, and it will become, solving this, it will become 2ws by 200 minus s. So this way also you can remember this formula without deriving it if there is any question related to spacing of or the width of terrace.